A design engineer is a general term for a person who may be involved in any of various engineering disciplines including electrical, mechanical, chemical, textiles, aerospace, nuclear, manufacturing, civil, systems, and structural/building/architectural. Design engineers tend to work on products and systems that involve the use and adaption of complex scientific and mathematical techniques. The emphasis tends to be on utilizing engineering, physics and sciences to develop solutions for society. While industrial designers may be responsible for the conceptual, aesthetic, and ergonomic aspects of a design, the design engineer usually works with a team of engineers and other designers to develop conceptual and detailed designs that ensure a product actually functions, performs and is fit for its purpose. They may work with industrial designers and marketers to develop the product concept and specifications to meet customer needs and may direct the design effort. In many engineering areas, a distinction is made between the design engineer and the planning engineer in design. Analysis is important for planning engineers, while synthesis is more paramount for design engineers. When the design involves public safety, the design engineer is usually required to be licensed, for example, a professional engineer in the US and Canada. There is usually an industrial exemption for design engineers working on project internal to companies and not delivering professional services directly to the public. Design engineers may work in a team along with other designers to create the drawings necessary for prototyping and production, or in the case of buildings, for construction. However, with the advent of CAD and solid modeling software, the design engineers may create the drawings themselves, or perhaps with the help of many corporate service providers. The next responsibility of many design engineers is prototyping. A model of the product is created and reviewed. Prototypes are either functional or non-functional. Functional alpha prototypes are used for testing. Non-functional prototypes are used for form and fit checking. Virtual prototyping and hence for any such software solutions may also be used. This stage is where design flaws are found and corrected, and tooling, manufacturing fixtures, and packaging are developed. Once the alpha prototype is finalized after many iterations, the next step is the beta pre-production prototype. The design engineer, working with an industrial engineer, manufacturing engineer, and quality engineer, reviews an initial run of components and assemblies for design compliance and fabrication/manufacturing methods analysis. This is often determined through statistical process control. Variations in the product are correlated to aspects of the process and eliminated. The most common metric used is the Process Capability Index (CPK). A CPK of 1.0 is considered the baseline acceptance for full production go-ahead. The design engineer may follow the product and make requested changes and corrections throughout the life of the product. This is referred to as cradle-to-grave engineering. The design engineer works closely with the manufacturing engineer throughout the product life cycle. The design process is an information-intensive one, and design engineers have been found to spend 56% of their time engaged in various information behaviors, including 14% actively searching for information. In addition to design engineers' core technical competence, research has demonstrated the critical nature of their personal attributes, project management skills, and cognitive abilities to succeed in the role. Amongst other more detailed findings, a recent work sampling study found that design engineers spend 62.92% of their time engaged in technical work, 40.37% in social work, and 49.66% in computer-based work. There was considerable overlap between these different types of work, with engineers spending 24.96% of their time engaged in technical and social work, 37.97% in technical and non-social, 15.42% in non-technical and social, and 21.66% in non-technical and non-social.